Everybody, it's Miss Barrett. Here we are again, and lesson 7, ladies and gentlemen. So today, what are we learning to do? We are adding and subtracting fractions, this time mixed numbers. So we're dealing with whole numbers and fractions. What am I looking for? Well, I'm hoping that you can interpret diagrams that represent fractions. And I'm hoping that you are able to still find the lowest common multiple, the LCM, so that you can determine the lowest common denominator, the LCD. Lots of vocabulary as per usual: mixed number, fraction, convert, representation, LCM, lowest common multiple, LCD, lowest common denominator, equivalent. Let's get started. All right, step 1, we know, look at the information given to you. Nothing really going on here, except for a couple of people cycling. Okay, let's have a look. There's a circular cycle route, 3 2/5 kilometre. So I wonder how far these chaps have cycled. Let's have a look. All right, on Saturday, Amelia cycles 3 2/5 kilometres with her dad. Okay, so we've got Amelia with her dad. Interesting that they're both wearing cycle helmets. Good stuff. On Sunday, Amelia cycles 1 1/3 kilometres. So the question is, in total, how many kilometres does Amelia cycle? Right, let's have a think about this. We have got 3 2/5, we've got 1 1/3. Yeah, finding the total, that means the same as adding. So I need to add 3 2/5 and 1 1/3. So this is where we're dealing with adding mixed numbers with different denominators. So let's have a look on Saturday. According to the information, Amelia cycled 3 2/5. Let's have a look at how that's represented on our fraction bar diagram. So we've got the equivalent to 1 whole kilometre, which is 5/5, agreed? And another whole kilometre, 5/5. So altogether we can see 2 have been represented so far, and there is our third and final whole kilometre and another 5/5. So this last little bit represents 1 2/5 of the kilometre that she went after the 3 whole kilometres. All right, we're good with that. How about Sunday? Here we go. Okay, apparently according to the information, Amelia cycled 1 1/3 kilometres. So we have 1 whole kilometre here represented, or the equivalent to 3/3, and then 1/3 of a kilometre left. So what do? Well, the first thing you must do when you are dealing with adding a mixed number is to add the wholes. That's fairly straightforward. So we've got 1, 2, 3, 4 whole kilometres represented here, as you could see. 1 whole, 2 whole, 3 whole, 4. So altogether, in terms of whole kilometres cycled, Amelia has cycled 4. And now that leaves us with 2/5, and we're going to add that to 1/3. And this kind of harks back to previous lessons, whereby, all right, we've got fractions here with 2 different denominators, and so we need to find a common denominator. So the first step will be to find our lowest common multiple of 5 and our lowest common multiple of 3, and let's see where they cross. So let's have a look. Okay, multiples of our denominator here, we've got 5. So we can have 5, 10, 15, 20, 25, 30, 35. But my knowledge of something common to 5 and 3, it's got to be 15. So let's have a look. Yeah, multiples of 3, 3, 6, 9, 12, and the lowest common multiple is 15. So we are dealing in 15ths. So how do we turn 2/5 and 1/3 into 15ths? Wow. This is where we need to multiply our denominator here by 3, and that will give us our 15ths. And what we do to the bottom, we do to the top. So let's go for the numerator of 2 2/5. We'll multiply that by 3 to give us a new numerator, the equivalent of 6/15. So 2/5 is equivalent to 6/15. All right, so now we need to deal with the thirds over here. We need to turn 1/3 into 15ths. So we we are going to multiply the denominator by 5 because 3 lots of 5 are 15. Excellent. What we do to the bottom, we do to the top again. So we multiply the 1, the numerator, by 5 to now give us 5/15. So we are now in a position where we have the denominator is the same for both fractions, and the rule, simply add the numerators to give us the total. So represented on a diagram, 6/15, you have 6 spaces equally represented out of a possible 15. You have 5 here out of a possible 15, and to find the total, we just add together. So 6/15 plus 5/15 gives us 11/15. Represented here, you could see your 6/15 in yellow, our 5/15 in red, and total together gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11/15. Okay, so in total, Amelia cycles 4, remember the 4 wholes, 4 whole kilometres and 11/15 of a kilometre. Now that's the total that she cycled over Saturday and Sunday. Okay, so what happens where Amelia cycles more on one day than the other? The question here, how many more kilometres does Amelia cycle on Saturday than Sunday? All right, 3 2/5 of a kilometre on Saturday. Yep, I can remember that. And on Sunday, 1 1/3 kilometre was cycled. So it's asking us, because it's saying how many more than, to find the difference or to subtract. So the calculation that we are going to do is we are going to subtract 3 2/5, subtract 1 1/3. How do we do that? Okay. Well, how can we subtract our mixed numbers where the denominators are still different? Let's have a look. Okay, we've got 3 2/5 travelled on the Saturday. We're going to subtract 1 1/3. So we simply subtract the whole numbers first, and we can deal with that here because we have got our 3 from 3 2/5 represented in yellow, and we have our 1 whole kilometre represented in red. So where we subtract, simply 3 take away 1, we just need to take 1 away, and that gives us a total of 2. So the difference in kilometres, the whole numbers, the integers, is 2. Now we're left with the fractions. Now, please forgive me, that is not an addition sign. I'd like you to imagine that that is a subtraction sign. So we are going to subtract here. 2/5 subtract, please forgive me. Yes, I know it's a mistake. 1/3. How do we do that? Well, we have the same issue where the denominators are different. So we need to find the lowest common denominator and think about our multiples again. So the denominator still, it's got to be 15 because the lowest common multiple, of course, of 5 and 3 happens to be 15. So same business, multiply the denominator by 3 to give us 15ths, the numerator by 3. So 2/5 is equivalent to 6/15. And showing on a diagram, we've got our 6/15, 15 equal spaces, of which 6 are represented in yellow. Okay, so 6/15 on our bar fraction diagram, 6/15. And it's subtraction, and yes, I'm wrong, but I'm correct here. We need to do the same and convert a third into 15ths, bit like we did before. So how do we get from 3 to 15, thirds to 15ths? Well, we need to multiply by 5. So the denominator of 3 multiplied by 5 gives us 15ths, and what we do to the bottom, we do to the top. Okay, 1 lot of 5 gives us a new numerator of 5/15. So represented here, 5/15 in red, we have 1, 2, 3, 4, 5 out of a possible 15 equal parts. So It's simple. Now the denominators are the same. We are dealing with the numerators, where we simply take away 6, take away 5, leaving us with 1/15. So the difference between the distances cycled on Saturday and Sunday, we've got our 2, which we mustn't forget from the whole integers, the whole numbers, and then we've got our fraction of 1/15. So Amelia cycled 2 1/15 kilometre more on Saturday than on Sunday. All right, I hope you managed to get your head around that. Where next? Let's have a look. Let's think together and see what Lewis has done. Well, according to the problem, Lewis walks 2 1/4 kilometres on Saturday and 2 3/8 kilometres on Sunday. So I guess the question is, how far did he walk altogether? Well, represented on our diagram here on Saturday, we've got our 1 and we've got our 2 whole kilometres, and out of a possible 4 quarters, one of them has been populated. And on Sunday, we're looking at 2 3/8, 2 whole kilometres. There's 1, there's the 2, and here the final kilometre is split into 8 equal parts, of which he has walked 3 of them. So we have got 2 3/8. So the first thing that you need to do to solve the problem, to find the total of 2 1/4 and 2 3/8, is of course to add the wholes. Then you need to add the parts, but you'll need to find a common denominator. And then is your final answer. So I want you to pause the video and see if you can have a go at adding together 2 1/4 kilometres and 2 3/8 kilometres to find the total. Make a note in your homework books and then unpause the video and we'll go through the answers. Okay, so before we pause the video, Lewis walks 2 1/4 kilometres on Saturday and then 2 3/8 kilometres on Sunday. I gave you the bar diagram representing those fractions and then some clues as to how to solve this problem to see how far he walked in total. Okay, so first thing you need to do, look at the whole numbers, the integers. And we can simply add 2 and 2 to give us 4. Give yourself a tick if you got that part. And then we're dealing with the parts. Well, we've got a quarter and then we've got eighths. And I know that 4 and 8 has a relationship. And I know if you double 4 times it by 2, you could turn a quarter into eighths. And that's what this bit is asking you to do. So to use our denominator of 4 and to find the equivalent in eighths, we need to multiply by 2. So what we do to the bottom, we do to the top. So a quarter is the equivalent to 2/8. Now, here's the original calculation, a quarter plus 3/8. But remember, we need to convert. So in this section here, we now have our quarter converted to 2/8, and we can now add that to 3/8, giving us a total of 5/8. Give us a tick. Yay! However, our final part here, we need to populate the final answer. It's asking 2 1/4 add 2 3/8. Well, this is where our whole number goes. Okay, so 4 whole kilometres have been walked. And then here is the fraction, and the answer will be in eighths. So 5/8. The final answer, which is clearly written, Lewis walks 4 5/8 kilometres in total on Saturday and Sunday. Thumbs up. I hope you understood. So let's try a further problem. In our think together here, we've got Jamie and Anne Beaker. Jamie swims 5½ lengths of a swimming pool and Beaker swims 3 2/5 lengths of a swimming pool. Question being, how many more lengths does Jamie swim than Anne Beaker? Many more. That means subtract, find the difference between the two amounts. Here we go. Okay, clues. Whole numbers. Think about what you need to do with those first. Common denominator. And then do the subtraction. Finally, populate your final answer box. Okay, in a moment, pause the video and let's see if you can calculate how many more lengths Jamie swam than Ambika. Okay, see you in a moment. Right, before you paused, Jamie swam 5.5 lengths of a swimming pool and Ambika swam 3 2/5. The question's asking how many more lengths does Jamie swim than Ambika? Well, before you paused, I asked you to consider whole numbers, common denominator, subtracting the fractions before you could populate the final answer at the bottom. Well, let's deal with the whole numbers first. What have we got in our mixed number? 5 and 3. So 5 subtract 3 gives us 2 whole lengths difference. Cool? What about the common denominator? Well, to convert halves and fifths, the common denominator I would say is 10, and that's the lowest common denominator. So we need to go from a half to tenths. And to do that, we multiply by 5. So what we do to the bottom, we do to the top. So a half converted into tenths will be 5 tenths. 2/5, we need to get to tenths again. From 5 to 10, we need to double. So what we do to the bottom, we do to the top, giving us an equivalent in tenths of 4 tenths. And now we can populate the subtraction part. So a half subtract 2/5 is the same as saying 5 tenths subtract 4 tenths. And because the denominator is the same, we deal with the numerator and it leaves us with 1/10. Okay, final answer, 5.5 subtract 3 2/5 is the same as 2 1/10. So Jamie swims 2 1/10 more lengths than Ambika. How did you get on with that? All good, I hope. All right, it's your turn now. Adding and subtracting fractions. There are 3 pages of which the first 2 are shown here. Some clues really in the speech bubbles, and it's interesting that you read and take note of what our friends are saying. Remember, you need to find the lowest common multiple of 4 and 6 in this case. Think of the first number in the 4 and the 6 times table that is common to both of the denominators. And that's always a good piece of advice. Same with where you've got a mixed number, add the whole or subtract the whole numbers first, then deal with the fractions. All right, here's the third of the 3 pages with the reflect. It's asking you to explain your answer. I would be expecting you to use vocabulary, mixed numbers, whole numbers, integer, if you wish, common denominator in your write-ups. Okay, if you fancy a little bit more of a challenge, here we have Richard Stadd making a model railway 2 3/4 meters long. He buys a second train track and that's 3/5 of a meter shorter. So you're already launching into subtraction. He puts the tracks together and then makes a new track. How long is the train track? Okay, plenty to think about. Well done, everybody. That's lesson 7. Tick, complete for the 17th of November. We look forward to receiving your work today. And if you've got any questions, you know how to get in touch via Class Dojo. Myself, Mrs. Lodge, if you need to, or Mr. Hall. Okay, people, take care and thanks very much, and we'll see you soon. Bye.